Hey guys, the objective of this video is to do an example using the frame element. The process is exactly the same as we've done before, that being the beam and truss element. So we're going to be defining the degrees of freedom and location vector. We're then going to be finding equivalent loads and fully fixed conditions. We're then going to be developing a stiffness matrix. We're then going to develop this equation here, Q equals KD. We're then going to solve for the unknown displacements, then the unknown forces. We're then going to check equilibrium to see if it makes sense, and then we're going to find our local reactions Q, which equals K1D plus the internal fixed. So here's our problem. We have a cantilevered beam, which is supported by a roller over there. As you can see, we have 20 kilonewtons pulling this way. So in this example, we have downwards load, we have moments, and we have axial load, which means we need to use the frame element. The other elements would not work, that being the truss and beam, because it can't handle all three actions. So we know the frame element has all three components, like this. So it has vertical, horizontal, and moment. I'm now going to define a location vector. So I'm going to put it going that way. So we're going to be going from A to B. Now we need to label the degrees of freedom. Now, exactly like before, you always want to label the ones which are free to rotate or move first. So as you can see, we have free movement in the X direction here, and we have free rotational movement there. So we're going to label those two first. Those are the only ones that are free to move. So 1, 2. Everywhere else is restrained. Vertically here, all those are restrained, and they're not going to move, so then we label the rest. So 1, 2, 3, 4, 5, 6. It doesn't really matter what order you label them in. All that matters is you have to label the ones which are free to move first, that being vertically, horizontally,